Integration by substitution. Okay, any idea how we do this without actually integrating?
Um, Not really.
I think you could graph them.
Okay.
So that's my thinking. And you could sketch them.
So would you sketch like for the first graph of x, or would you have to do like the graph of the integration?
So I'm just thinking the like y equals x for the
You would do
first one.
x, right?
Yeah.
Yeah, okay. Okay. So
Um,
that would be like a triangle, so the area.
yeah. And I'll just say that's 1, 1. I don't know. Okay, so how about second graph?
Um, X. Exponential? Would it be an exponential graph?
The square root one?
Yeah,
And do you know what it will look like?
not really.
I
Oh, it's
think
gonna be like that and like that, right? I don't know how to draw it, but
I think it's kind of like that,
oh, okay.
where it slowly levels
Okay.
off. I don't know if that's right. And the last one, 2 to the x minus
I don't
1.
know what it's called, but it's that one that's like this and then
So that's, exponential.
oh, okay. Oh,
Um, but
no, the other one. I don't know. I'll try drawing it. I don't know what it's called, but
so when
it's
x
like
is
this.
in, one sec. You're thinking of reciprocal 1 over x.
Okay. That's not that one then.
So this one, when x is 0, you get 0. So I think this one, I'll make a different color. I think this one is like that. So they all go through 1. They'll go through 1, 1, I think. And so
Hmm.
you have to say, if integrated, which one is the smallest, which one is middle, which one is most.
I think X would be the most. Wait, no,
Okay.
it's area under the graph, right?
Yeah.
So 2x to the minus 1 would be the most. And then x, and then root x.
So this black one is 2 to the x minus 1.
Okay, then I meant root x is biggest, and then x, and then 2 to the x minus 1.
Now that's assuming I've sketched these correctly. This one is y equals root x. Did I? I think I did. And so that one's the smallest, that one's the middle, that one's the most. Yeah. So they all go through 0, 0 and 1, 1. But yeah, so it's based on area. All right. Any questions there?
No.
All right. What's that about? Okay. Oy, oy, oy. How are we doing this one?
Um, I don't really know. I didn't even get like the first part.
Um,
Oh, partial fractions? Is it? It looks
um,
like partial fractions,
I
but
think I think this is just separate entirely from the integral. Like we might use it for part 2, but just separately. Yeah, sine x is equal to this. Find the values of the constants a and b. Any idea how you do that?
um, wouldn't no, not really.
I
Because
think
so wouldn't they just be zero or something?
I think you're onto something. So expand the brackets. What would you get? What do you get if you expand the brackets?
Minus a sine x plus cos a cos x plus b cos x plus b sine x.
What if I was to write that with the x's together, sorry, the signs together, and the
Minus a plus b is equal to 1.
Yeah.
And then a plus b is equal to 0. And then simultaneous equations.
Yeah.
I would just give you b is equal to 1, I think. And a is equal to 0. Wait, no, a is not equal to 0. But b is equal to 1.
Sine x
is equal
to cos x. So yeah, a plus b is 0. Minus a plus b is...
b is 1. Is b 1? I don't know. Oh, b is a half. And a is minus a half? I don't know if that's right.
b is a half, a is minus a half.
I don't think that's right. Is it? Because minus a... Oh yeah, it is. Never mind. I confused myself.
And then part 2.
Into 2 integrals. Wouldn't that be partial fractions then? If you split it into 2?
It says using part 1. So using part 1. Oh, okay. So split I into 2 integrals. How can you use part 1?
Partial fractions with that denominator, with those denominators. Like you have to do minus a half, minus 1 over 2 cos x plus sine x, I think.
Yeah. So, well, sine x is...
Yeah, I don't get that part because it says only sine x. So the partial fractions is just for the sine x bit. So what about the denominator?
So instead of sine x, you would write, so that's the integral of minus, integral between pi over 2 and 0 of minus a half minus sine x plus cos x, and then plus a half cos x plus sine x.
Okay.
And you would then put those two as separate fractions, I believe. So that is over cos x plus sine x, and the second one.
Oh, you could do like cos x plus sine x is equal to u, and then like by substitution.
Notice anything about the second one?
You can cancel out the cos x plus sine x.
So I think that's what they're getting at there.
Okay.
Okay. And anything else?
Not really.
What is the derivative of cos x plus sine x?
Oh, minus sine x plus cos x.
And so
there's an integration thing for that, but I forgot what it is.
Cos x, so that will be the ln thing?
Yeah, the ln of cos x plus sine x, right?
So minus a half ln. minus sine x plus cos x, or just both positive?
Oh, do
Oh,
you have
sorry.
to put in like the differential, the actual function?
No,
Like,
sorry. It's the denominator. Sorry. So ln of the denominator, integral of a half with respect to x.
Half x. Wait, no, 2x. No. Is it half x?
Half x. And that's between pi over 2 and 0.
Yeah. And then you have to solve that. So calculate the time. But you should have minus a half. Okay, so the first bit, if you solve it, you just get pi over 4. Like if you solve the whole thing for pi over 2. Yeah, I haven't done the 0 one yet, but I'm guessing it will just be 0.
I believe so, because you get cos 0, which is 1.
Yeah.
Ln of 1 is 0. And sine 0 is 0.
Yeah.
And
Yeah.
so
And
you end up...
you see 0.
Yeah. And so you just get pi over 4. Let's see. Yeah. So those cancelled. Okay. Pi over 4. Just want to see. Okay, big picture. So it was given to us that sine x is equal to this plus that, where those are constants. Expand the brackets, factorize, and then compare the coefficients to get simultaneous equations and solve. Second part, using part 1. So instead of sine x, you write this, what sine x is equal to. And then they said split it into 2 integrals. And so it's 2 separate fractions. First one and second one. Second one simplified down to a half. The first one, the numerator was the derivative of the denominator, and so it was the ln type. Any questions there?
Yeah.
Tricky. Okay, what is this?
Okay, so it's the integral of 1 minus cos squared x sine x.
I don't know. So sine cubed x
is equal to 1 minus cos squared x times sine x.
Why is that?
Because 1 minus cos squared x is equal to sine squared x.
So it's a kind of show that type of question, I think. Oh no, it isn't.
No, it's just find the integral.
Okay. And so how do we go about this one?
I think you would do maybe u is equal to sine x, and then du by dx is equal to cos x. Is it cos x minus cos x?
Do you know the integral of cos squared x?
No.
Could do it twice, I suppose. And so, okay, so if u is sine x, and so du by dx?
Du by dx is minus cos x. Is that right? Or just cos x?
Cos x.
Yeah.
So dv by dx is 1 minus cos squared x.
Yeah. And then we don't really know how to integrate that, but x minus something.
This part here, the integral
Yeah.
cos squared x with respect to x.
Is cos squared x integrated like minus a half sine 2x or something? I don't know. I might have just made that up.
Might be onto something there. You could always say like u equals cos x, and dv by dx is also cos x.
Okay. Oh, so you did twice.
And so du by dx
Is minus sine x. And then when you integrate that, you get sine x.
equals sine x. And so, does that work? Or does it just get worse? Do you remember the formula?
Yeah. I mean, I don't know the formula, but like my maths teacher taught us like a good way to do it. So I know how to do it.
Okay.
I don't know the formula.
What's
So
your...
it's cos x sine x.
Okay.
Oh, I don't really need it, but okay.
Cos
So
x sine x?
cos x sine x minus the integral of minus sine x cos x.
Will this just go on forever? I think it will, because it's trig, won't it?
Yeah.
Let me see. Sine cubed x. That is the same as, if we were to expand this bracket that they gave us,
Yeah.
that would be sine x minus sine x cos squared x.
I don't think, is that helpful? I don't think it is.
And the integral of that will be minus cos x. I'm thinking we make the cos squared x the derivative thing. So make that the u.
Sorry, what's the u?
So make u be equal to cos squared x.
Okay.
And dv by dx sine x.
Okay. So how do you differentiate cos squared x?
Let's see. So I was thinking of it as like cos x all squared. So that would be 2 cos x and then times by the derivative of cos x.
Yeah.
What is that?
The derivative of cos x is minus sine x.
So that'll be minus. Okay. So that's du dx. Well, does it always give us that problem though? So v minus cos x. So v du dx. The integral of that is the integral of cos cubed x. Just creates a loop, I think. Is there some method for integrating? It says integration by substitution.
Yeah, that's when you do like u is equal to something, and then you do like du by dx. There's no formula for it.
They're supposed to give us the substitution. Maybe like u.
Yeah, usually they do. I don't know.
how did I try this? Okay, so sine cubed x is sine squared x times sine x. 1 minus that. I expand the brackets. Yes. So I was looking at the answer. Minus cos x. So the integral of sine x is minus cos x. It said the integral of
How you know that?
So I wasn't sure where that came from though. Where does that come from?
How can you have sine x, but then you just get 1/3 cos cubed x? Like, how does sine x become cos cubed x?
I think.
Oh wait, sine x doesn't it integrate to like minus cos x?
Yeah.
So then they just multiplied the minus cos x and the cos squared x, so then it became 1/3 cos cubed x. I don't know if that I don't really get where it came from.
So the derivative of this is cos squared x sine x. Yeah. That's pretty magic. So,
Yeah, but how are you meant to like know that and solve this question?
Yeah.
Like, we don't learn that, so I don't understand how you're meant to do it if you don't know.
So
like, you have to be given that or something to be able to do the question.
Cos x cubed. So yeah, what they did was it's like 3 times a third cos x squared and then times the derivative of this, which is minus sine x, which ends up being 1. That's cos squared x and that's minus sine x. Yeah, but how would you know that without the answer?
Exactly.
That's tricky. Okay.
And the other one
Plus
as well.
Plus 1/3. Okay, so what was that one? So sine x. Lost it. Minus cos x. Okay, part 2 wants us to do some stuff.
Okay, so I guess you would do 1 minus cos squared x sine x to the power of 4.
Okay. Integral of sine x. Okay, what's next?
Expand the bracket.
Okay.
Oh, why did you do 1 minus cos x to the 4? I thought it was sine x to the 4. And then 1 minus cos squared x.
Yeah. 1 minus cos squared x to the 2. Sorry. Is that right?
No, I don't think the bracket should be to anything. It's just sine x to the power of 4.
So sine.
It's just 1 minus cos squared x and then sine x to the power of 4. Like sine to the 4 x.
So this is how I'm thinking of it. Like that, basically.
Kind of, yeah, I guess. Yeah, it's the same thing. But it should be, shouldn't the sine x shouldn't it be, yeah, 1 minus cos squared. Oh, okay, I get it now.
It just might be easier for. Okay.
Yeah. And then expand.
Yeah.
So sine x, and then that would be 1 minus 2 cos squared x minus cos to the 4x.
Plus, I believe. Minus times minus makes plus.
Yeah. And then that would be sine x minus 2 sine x cos squared x. Plus sine x cos to the 4x. And then, so sine x integrated gives you minus cos x.
Yeah.
2 sine x cos squared x. That would just be 2 times the integral, like it would be 2/3 cos cubed x.
Yeah.
And then, I don't know what the last one would be.
Would it be 1/5?
Yeah. That makes sense, because that one was 1/3.
So 1/5, what is it?
Cos to the 5x.
I believe so. Plus C. How about this weird one?
Which way? Oh, that one. Okay. Cos cubed x sine squared x. I really don't know. Well, sine squared x is 1 minus cos squared x, if that's helpful.
Okay. Okay.
Well, cos to the 5x integrated is 1/5. Wait, no. Something integrates to that. In the previous question, didn't something integrate to 1/5 cos to the 5x? So the integral of that should. Oh yeah, I don't know what the integral of that should be.
Let's see. What is the integral of cos? Sorry, the derivative of cos to the 6x.
6x. 6 cos x to the power 5 times minus sine x. Or times sine x. And minus sine x.
So, but this doesn't have a sign. Maybe we were supposed to keep the sign. Yeah, we were.
Then what about the cos cubed x? Because that would become 1 minus sine cubed x.
I don't believe it would. It'd be sine x times 1 minus. Hang on, cos x times 1 minus sine squared x. Is that right?
I think so.
So cos cubed x is cos x, cos squared x, sine squared x. So why couldn't these be added and just become 1?
Because they're being multiplied.
Minus sine
So
squared.
I'm not sure if you can add them.
Oh, you definitely can't. I'm just lamenting. Okay, so that's what we have. Is there some way to end up with 1x? Sorry, like sine of 1x or something like that.
But then if you expand that, it would just be like all the cos and sines would be like mixed and stuff. So it'd still be hard to integrate. I actually don't know how to do this.
Cos x.
Could you just integrate each of them separately? Or can you not do that?
If you know how to. I just have an idea. Sine squared x cos x minus sine to the 4x cos x. So it's kind of the other way around this time. What is the derivative of sine to the 5x?
5 sine to the 4x times cos x.
4x cos x. And so what is the integral of sine to the 4x cos x?
1/5 sine to the 5x.
Sine to the 5x. And so the integral of this part is 1/5
Is 1 sine to the 5x.
x. Can we do something similar for this one?
Yeah, there should be maybe sine to the 3x.
Yeah.
Differentiate into something similar. So it'll be 3 sine squared x times minus cos x.
Positive cos x, I think.
Okay. So that would be 1/3 sine cubed x.
Sine cubed x minus 1/5 sine to the 5x. Let's take a look. 1/3 sine cubed x minus 1/5 sine to 5x plus c. So it's just the other way around this time. Plus c. So it's just the other way around. You yeah, you can, if you have like one x by itself or one sine x by itself or one cos x by itself, you can use that for integrating, and it really helps to kind of go a power higher, differentiate, and then work in reverse to see what the integral would be. Phew. Let's see. Yeah, any questions about that?
No, I mean, one side did it. It's not that bad.
Yeah, so you write it as something and then with one sine x or something with one cos x. Okay, this one I did not get a chance to look at. We'll see what this is about.
Explain what this tells you. Why? What does this tell you? Well, I don't know what it tells you. Oh, fx is equal to f pi minus x. Isn't that like sine x is equal to cos 90 minus x or something?
I think
A different thing.
yeah, you have the right idea. So x is equal to pi minus x.
Sine x is equal to cos x or something.
If you bring the x's to one side.
2x, yeah. X is equal to pi over 2.
And so
it's a straight line.
I think not necessarily. I think that's the line of symmetry. That's the mirror line.
I always see these questions about like line of symmetry, but we never learnt it, so I'm not sure if we need to know it or not. Like when we did functions, we never did. And I see these questions that like, what does this tell you about like, trying to remember what they say. It's like about the reflection of the graph or something. But when we did functions, we never did that, so I don't know.
I think that might have to do with signs like modulus stuff. I think that's what.
Whenever I look at the answers, it's like f of x is equal to like minus f of x or something.
So that's reflections, yeah, transformations,
rotations, and I've literally never seen that. So.
Yeah, they should have done that. I don't know if I'm even correct. The graph is symmetrical, but the line x is equal to a half pi. Okay, so all right. Part 2.
Like we didn't do this like line of symmetry stuff, so
Okay. Let me see. So f of x equals f of sorry, equals f of pi minus x. So I just said x equals pi minus x by inspection. X is a half pi. I think it was like what you said, to be honest. Like with a sine graph. You have, so this goes to 180, and so it's symmetrical about 90. Like x equals 90, and pi minus x pi is 180, 90 is pi over 2. Yeah, I believe that's where it comes from. It's like sine graph, how the graph between 0 and 180. Let me see. If it satisfies all of those values, then it must be symmetrical about halfway from 0 to pi. I think that's it, really. So if it's from 0 to 180, if all of the y is equal to the f of x, it satisfies f of x is equal to the f of pi minus x. So let's see, but we'll inspect f of x. If that becomes the f of minus x, what's happened there?
A rotation.
So that's a reflection.
Reflection, yeah, in the y-axis.
Yeah.
I'm trying to relearn graph transformations again because I forget them like every week.
So that is a reflection, and then f of
X-axis. Okay.
f
Translation by pi units. No, by minus pi 0. Oh, is that the y one? The y translation? I have no idea.
You're correct.
Okay.
So that's translation by the vector. So that one's translation, and that's by the vector minus pi 0. So that would move the graph like that.
Yeah.
And let's see, so this is I don't know. I think we just have to do that whole thing separately. Like this is that bit there was like one mark question or something, I imagine.
Okay.
You'd have to do it, but it's a series of transformations, and one of them is a reflection. Okay, part 2. You're gonna have to help me with this one. Okay, so this is substitution.
So y equals pi minus x. Sure. Okay, well, since y is pi equals pi minus x, then f of pi minus x obviously is equal to f of y. Not really sure where they got the dy from, but I'm guessing that's because it's in terms of y, so it has to be dy.
Find the derivative. What is dy by dx of pi minus x?
-1.
Therefore, what is dy?
Minus dx.
Therefore, what is dx?
Minus dy.
dy. And so, what can we write there?
You can put minus dy there instead.
Okay, what else can we sub in?
X is -1. Wait, no, never mind. F of x is the same. Wait, how did they go from f of x to... Oh, f of x is equal, okay. So yeah, you could put f of y instead of f of x because they're equal.
They're definitely not equal.
If you substitute y equals pi minus x, then yeah.
Okay.
And that's equal to f of x.
So the f of pi minus, instead of x, you do pi minus y. Yes. So that is the f of y.
Yeah. I don't know why would it be minus I?
Do they?
Because it just says I equals something minus I. Yeah.
What's that mean? It's equal to 0? It's a strange thing to see.
I think that might be meant to be that.
We'll get there. Hold on. So I equals, let me just see, the integral between pi and 0 of x, df of x, and dx. So we said that dx can be replaced with minus dy.
Yeah.
I'm going to put that minus to the front or something.
Okay.
Minus, so integral. What can we put instead of f of x?
F of y. dy.
What can we put instead of x?
Y?
I think it would have to be pi minus y, would it?
Yeah, okay.
Pi minus y. Let's see. And so, if we were to expand, do we expand this?
Can you expand that?
I believe it would be, yeah, so it would be pi the f of y minus y the f of y, all with respect to y. Or is that kind of going the wrong way? This I here, that would be the same as, so is this here, y f of y, is that the same as x f of x or something?
Not sure.
I'm not sure. We had to change this thing. So when it's with respect to x, it's between pi and 0. So what would it be when it's with respect to y?
Well, y is pi minus x, so the pi limit would go to 0.
Yeah.
And then the 0 limit would go to pi, so it would just be...
So it stays essentially the same. Okay.
Yeah.
Let's see. And show that. So, what are they saying? So, they're saying that pi is brought out. you have between pi and 0 f of y with respect to y, but then minus I. So that
Where
means
did the pi over 2 come from?
well, what is the f of y?
F of y. Well, it's the same as the f of pi minus x, but I don't think it's useful.
I'm missing something. Taking a lookie. So y equals that. So dx equals minus dy. So then you swap those two. That's okay. X is pi minus y. Yeah.
You know what I did, like, the last two steps? Like, they did pi minus y, f of y, dy, and then kind of like split them.
So
Looks like a combination of my parts, but I'm not sure.
whenever there was an x, they changed it into pi minus y.
Okay, yeah.
So that everything was y instead of x. So x is pi minus y, and then this x is pi minus y. This was with respect to y.
Yeah.
This looks similar. So
Isn't
that's
that what you did? Yeah. But
yeah, that the f of no, maybe not. So that is pi f of pi minus y f of pi minus y, and it's all with respect to y.
I think they split them into two integrals.
Two separate integrals.
Yeah.
So, okay, so we can bring the pi to the front for the first one.
And then minus y, the integral of y, f to the pi minus y dy.
Okay. Oh, is that a 1? Y f of y. Is that an I? That looks like an I here.
Yeah.
So I assume this is an I. Y the f of y with respect to y is that I or 1?
I don't understand this. It looks like a 1 in the answer, or like a L. I don't even know.
So I don't even know what the f of y is, though.
Yeah, I don't know how they suddenly just made it into 1. But it doesn't. I don't think it's a 1 because they always write 1 like that. So it's literally just like a I.
So if that's I, and
I don't know how I is equal to something minus I.
but I is x f of x with respect to x. How can I also be y f of y with respect to y? when y and x aren't equal. Because they're not. X is pi minus y. So I is integral of x, f of x with respect to x. They're saying, therefore, I is y, f of y with respect to y. But y and x aren't the same. That's the problem. If y and x were the same, I'd agree. If it has the same limits. Unless I'm missing something. Let's keep going with this thing. So this bit here, it seemed like they were saying you get 2I is equal to pi.
Okay, then you just divide by 2. That makes sense.
0.
Well, yeah, I suppose if you have I is equal to something minus I, wouldn't the first thing to do be to just add it to the other side?
Yeah, so
You
could
just have 2I is equal to everything, and then you just divide by 2. But I don't know how they got fx at the end again.
the f.
Because y
yeah.
minus y is equal to x or something. Pi minus y. Oh yeah, you have f of pi minus y. So you could just do fx there instead.
Okay.
Substitute. I don't know if that would work, but
Yeah, substitute back f of pi minus y. Okay, so I'm just kind of missing that one step in there. How you go from one to the other. Okay, part 3. Use part 2.
I didn't even get part 2. How are you going to use it to find stuff?
Like they gave us.
Okay, they give you the results, so it's not that bad. X sine x. That means f of x is sine x, so it's pi over 2. Pi over 2, like outside, and then pi and 0 is the limits, sine x dx. So the integral of sine x is just minus cos x.
Mm-hmm.
So then it's just, yeah, minus cos x. When you have something outside like that, do you have to do pi over 2 times minus cos pi and then minus, or do you do like the whole integral and then times of pi over 2?
Just times your final answer by pi over 2.
Okay. Minus cos 0, which is 1. But
I think it's minus minus, is that right?
oh yeah. Yeah, it is. So minus cos pi is the question. Minus 1. So that would just be 0.
And so pi over 2 you get 0.
Yeah.
We can't be getting an area of 0. Hang on. X sine x. So the f of x is sine x. I think so. Sine x is equal to sine pi minus x. That's true. Sine x, the integral is minus cos x. Did we do that? Yeah. It's minus 1 at the start. There's missing a minus here. Let's see, minus cos pi. Yes, so it should be minus 1. So it ends up being 1 plus 1. Do you get that part?
Yeah.
And so it is pi over 2 times 1 plus 1. And so what do you get there?
Pi, that's just pi.
And this thing here.
Fx is equal to sine cubed x.
Mm-hmm.
And then, so then you have to integrate sine cubed x, which is minus 1/3 cos something.
What would be the derivative of sine to the 4x?
4 sine cubed x times minus cos x times cos x.
Hang on. Does that help us? Or not? Use part 2, f of x. We could do sine squared x times sine x, something like that. Does that help? So that's the same as... Hang on, so we had to do the integral of sine cubed x.
Mm-hmm.
Integral of sine cubed x. Did we do that earlier? Integral of sine squared x sine x.
Yeah, I think we did it earlier. Just go back.
Integral...
It was the next question. The one after this one. After. Question 3. Yeah.
Sine cubed x.
Where the answer is.
Wherever. We got it, I remember. Wait, this was part 1, was it?
Yeah.
Wow. Was this really sine?
Apparently.
Hang on. That was...
Just check the answer. Like, the next.
3.1.
No.
That was the answer for part 2 or something. Or part
3.
Yeah.
That
Because I copied and pasted them out of order. Okay, so the integral of that is that.
That makes life easier.
Yeah.
And then you just have to pi over 2 and solve it, basically.
Pi 0.
Sine cubed x.
Yeah.
Wait, why did you put the integration sign if it's only...
Sorry, so it's a square sign. Is that right?
Square sign? Yeah.
Cos x.
Shouldn't there not be... Oh, never mind. I was about to say there shouldn't be a plus c, and then I realized that was a different question. Okay. So, minus cos pi. Okay. So 1. It's not really a exact form answer.
What are we subbing in here? Pi? What is cos of pi?
Minus 1.
And so...
So it's just 1 plus 1/3 cos cubed pi, which is not an exact answer.
we should be able to get an exact answer. Degrees. Sorry, degrees. Radians.
Yeah, I thought it was. Oh, maybe I'm in radians.
So, this one here, cos pi is what, -1? Cos pi is -1. And then when you cube that, you get -1. And times a third minus a third?
Yeah.
Let's see. So cos pi, and just to... So if I put a bracket around that, and then... So that's a bracket around the whole thing. And that's the power of 3. Yeah. What decimal are you getting?
I don't know, I got 1.305 something.
So it should be like cos pi.
Maybe, I think I did cos like pi cubed and not the whole thing, and that's probably why.
Yeah, that's what it is. Okay.
I got 26/27. My calculator, there's something wrong with it.
You're doing like 1 minus or something.
I did 1 plus, because it should be 1 plus.
Okay. I'm doing them separately. So like.
Okay.
I just left that first bit as like -1.
Okay.
Then this bit is So that might be what that first bracket is.
Yeah, the first bracket in like everything, like the whole first bracket is 26/27.
I think your brackets. So 1/3 cos cubed x. That's the same as 1/3 cos. We're putting in pi. Cos pi cubed. Is that right?
Yeah.
Bidmas. Indices. So cos pi is -1. -1 cubed.
-1 cubed -1.
And then times a third.
A minus a third.
Yeah, so you're getting -1/27. And then you're doing 1 minus that. You get 26/27. It should be just 1 minus a third.
Hang on, I probably made another mistake somewhere.
And then sub in 0.
So cos 0 is 1. So that would give you -1. And then cos 0 cubed is also 1. So 1/3.
Okay. And so what I'd do is I'd expand that second bracket using -1. That's another way to subtract it.
Yeah.
So what do you get?
Plus -1 plus a third. So the second bracket would be -2/3.
Yep.
And then plus 2/3. So that would just be 4/3.
Yeah.
Times pi over 2. So 4 pi over 6, which is 3 pi over 2. No, 2 pi over 3.
6, which is 3 pi. Sorry, 2 pi over 3. Oh, it better be 2/3 pi. Well. Integration by substitution. One of my least favorite things.
It didn't even have integration by substitution in this, apart from this one question.
It was a lot of integration and stuff. So they did sine cubed x is sine cubed pi minus x. Yeah, same stuff. All right. Any questions there?
No.
Bananas. Anyway, how was that for you, Amogha?
A bit hard, but not that bad.
I agree.
Done integration in a while, so.
anything in particular you want to do next time?
I'll just send questions again.
Okay. Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.